Hey y'all, this is 4-2, standard form of a quadratic function. All right, so we're going to learn today how to graph in the form y equals ax squared plus bx plus c. All right, so what you do here, you identify a, b, and c. We're going to find the vertex, doing the formula negative b over 2a. Then you substitute that in to find y. Find and sketch the axis of symmetry, which we know goes through the vertex, the vertical line. Plot and reflect the y-intercept, which is just the value of c. And then the one you can't see on the screen right there that you can see on your paper. Evaluate A, determine if it opens up or down, and graph. All right, so here we go. Example 1. I can move that just a little bit. Nope, can't move once you're in. Y equals 2x squared plus 8x minus 2. So we're going to find the vertex. So the first thing we're going to do is negative b over 2a. So we know that a is 2, b is 8, c is negative 2. So to find the x-coordinate of the vertex, we would do negative b over 2a. That's to find the x-coordinate of the vertex. So that would be negative 8 over 2 times 2. Which is negative 8 over 4, which is negative 2. So the x-coordinate of the vertex is negative 2. Once we know x, to find y, we would substitute it in. So we would go y equals 2. We just found that x is negative 2 squared plus 8 times negative 2 minus 2. So let's see, order of operations, negative 2 squared is 4 times 2 is 8. Minus 16 minus 2. So that tells us that y is negative 10. So the y coordinate of the vertex is negative 10. So our vertex is at negative 2, negative 10. So we could graph that on our graph here. Negative 2, negative 10 is where the vertex is. So then we know the axis of symmetry is the line that cuts that in half. So it's always x equals, the x-coordinate of the vertex is negative 2. So we know the line cutting this parabola in half is x equals negative 2. It's always the vertical line going through the vertex. To determine if there's a max and min, we look at A. So looking here at A is positive. A being positive means that it opens up. If it opens up, it has a minimum value. That minimum value is whatever the y-coordinate of the vertex is, so negative 10. So we know the furthest this is going down on the graph is negative 10. So then to find our range, it's always going to have to do with y. Range is y. The minimum value is negative 10, so it has something to do with negative 10. I just have to figure out my inequality there, right? So the furthest it goes down is negative 10, and then it goes up forever, so it would be greater than or equal to. We can see that more than when we graph it also. So then to find another point in standard form, your y-intercept is always c. So our y-intercept here is at negative 2, which I can reflect to the other side, and then draw out my parabola. So then that helps you see the range too. You can see the range, the y's are being used. The furthest this goes down is negative 2. It goes up forever, which is why the range is y is greater than or equal to negative 10. Because the furthest it goes down is negative 10, and then it goes up forever. All right, let's look at another one. So here we can see A is 1, B is 2, C is 3. Vertex, negative b over 2a to find the x-coordinate would be negative, b is 2, over 2 times a is 1. So we've got negative 2 over 2, which is negative 1. So the x-coordinate of that vertex is negative 1. To find y, we would plug it in. So y equals negative 1 squared plus 2 times negative 1 plus 3. Which would be y equals negative 1 squared is 1, 2 times negative 1 is negative 2 plus 3, so that gives us 2. So our y-coordinate is 2. So the vertex is at negative 1, 2. So left 1, up 2. So we know the axis of symmetry is going to go through that point. His equation would be x equals negative 1 That always goes through the x-coordinate of the vertex. Minimum or maximum, let's see. A was 1, so A is positive, means it's opening up, so it bottoms out. It has a minimum value. So the furthest would be 2. So then our range would be, we know range is wide. It has something to do with 2. Since this is opening up, it bottoms out at 2 and then goes up forever. So it's greater than or equal to 2. To find our other point there, we know that C is equal to 3. So we're crossing the y-axis at 3, which we can also reflect to the other side to make our beautiful problem. Now, we'll find ways in the future to find more points to make that more accurate, but today in the standard form, we're just going through the vertex, identify the y-intercept, and reflect it over. All right, one more. This one is not so pretty. So we can see we've got A, B, C. So vertex is going to be negative B over 2A always. So here, negative 4 makes it positive 4. Over 2 times A is negative 3. So we have negative 4 6, which is negative 2/3. Ew. But it happens. Life ain't always pretty. So vertex x-coordinate, negative 2/3. Find y, we plug it in. So we go y equals negative 3 times negative 2/3 squared minus 4 times negative 2/3 plus 6. I'm using my calculator on that one, folks. Typing it in, I find out that I get 7 1/3. So negative 2/3, 7 1/3. I'm going to do my best here on this graph, about like right there-ish. Then the axis of symmetry is going to go through there. So our axis of symmetry is x equals negative 2/3. A is negative, so this opens down, so it's going to have a maximum value, right? It's going to max out at 7 1/3, which makes our range, we know it's y, we know it's 7 1/3. Since that's the top of the mountain this time and it goes down forever, it'd be less than or equal to 7 1/3. Right, so then to find our other points, we know that the y-intercept is the value of C, which is 6. So we're crossing here at 6. We're going to do the best of our ability, right? So this is 2/3 over, so going 2/3 this way. There we are. Again, we'll learn in the near future how to make more accurate graphs than that. All right, so that's graphing. Let's step away from graphing for a little bit. And the next one, we are just going to convert into vertex form. So you first find the vertex, HK, then use that and A to write in vertex form. So this is very similar to what we did yesterday. So here, the first thing you want to do is, so we're going to get into vertex form. So the first thing you do is you find the vertex. Right? Find the vertex like we just did. So A is 1, B is 2, C is 5. We know vertex, we go negative B over 2A. So here we have negative, B is 2, over 2 times A is 1. So that's negative 2 over 2, which is negative 1. So that's the x-coordinate of our vertex. So then we know to find the y-coordinate, we would substitute that in. So we go y equals, x is negative 1 squared, plus 2 times negative 1, plus 5. So y equals, you can either use your calculator. What I do is when they're simpler, I just do it in my head by hand. And when they're more difficult, like that last fractiony one, I throw up my calculator. So this would be 1 minus 2 plus 5. So I find out that y is 4. So that's the y-coordinate of my vertex. All right, so the first thing we do is we find our vertex. Then we're going to plug A, H, and K, right? A, H, and K into vertex form. Remember, that's y equals A times x minus h quantity squared plus K. So we know that A is 1. We know our vertex is HK. So we would go y equals, A is 1. You can write it or not, up to you. Parentheses, x minus, x coordinate of the vertex was -1. So minus -1 makes it go +1 squared plus K. The y coordinate of our vertex is 4. So there we are in vertex form, which is a lot more useful when you're graphing. If you just think about what we had to do to graph in standard form, we're in vertex form at y equals 1, invisible if you want it, times x plus 1 quantity squared plus 4.